In this lesson, you will learn how to solve one-step equations using addition and subtraction. The first step is to add or subtract the number on the same side of the variable to both sides of the equation. Step 2 is to check your answer. So we will follow these two steps for the examples below. So the directions are to solve each equation and then check your answer. So for each of the examples, I will solve the equations on the left side of the screen and I will show the check on the right side of the screen. So for number 1, x plus 11 equals 21. The goal of solving for x is to get x by itself. There is an 11 that is being added to the x. So to remove the 11 from the same side of the x is to take the opposite operation, which is subtraction, and I subtract the 11 from both sides of the equation. What this does is it isolates the variable x so that I have x equals 21 minus 11, which is positive 10. So the answer that I solve for x is x equals 10. And to show the check, to make sure that this answer is correct, I take the value of x equals 10 and I write the original equation, x plus 11 equals 21, and I substitute 10 in for x, and since both sides of the equation are equal to 21, x equals 10 is correct, so now I can put a box around x equals 10. For number 2, negative 26 equals b minus 4. Once again, the goal is to solve for the variable. The variable in this problem is b, but there is a 4 that is being subtracted from b. So we want to move the number over to the left side of the equation. To do that, we take the opposite operation. Since 4 is being subtracted, we now add the 4 because we're moving it over to the left side of the equation, and we take negative 26 plus 4. Negative 26 plus 4 is equal to negative 22. So the answer is negative 22 equals b, which we can reverse as b equals negative 22. But before I put a box around this, I want to check the answer. And I take negative 22 and substitute it in for b. And the left side of the equation is negative 26. The right side of the equation, since I'm subtracting sign numbers, I want to rewrite this as negative 22 minus a positive 4. And I do keep, change, change. And I can rewrite this as negative 26 equals negative 22 plus a negative 4. And when you add two negatives, the answer stays negative. So it's negative 26 equals negative 26. Since these two numbers match, the value of b equals negative 22 is correct. For number 3, x plus 5 equals negative 30. We want to solve for x but there is a 5 that's being added. So we subtract 5 from both sides so that we can isolate the variable x, and we're left with x equals negative 30 minus 5. If I write that out horizontally, negative 30 minus 5, it is the same as negative 30 minus a positive 5 and when I do keep, change, change, I end up with negative 30 plus a negative 5, which is equal to negative 35. So my value for x is negative 35. So on the right side of the screen, we will check this answer of x equals negative 35. So next to it, I write x plus 5 equals negative 30, and I substitute the value in for x. Negative 35 plus 5 is equal to negative 30, so the two sides match, and the answer of x equals negative 35 is correct. For number 4, y plus 2/3 equals 5/6. So this equation involves a fraction, but that's okay. For number 4, y equals For number 4, y plus 2/3 equals 5/6. So to solve for y, I have to isolate the y by subtracting 2/3 from both sides since it's being added. So I take 2/3 minus 2/3 and then 5/6 minus 2/3, which I will write out on the side. 5/6 minus 2/3. To subtract these fractions, I have to find a least common denominator. So I list the multiples of 6 and the multiples of 3. And the smallest number that they have in common is 6. So the least common denominator is 6. I want both denominators to be a 6, so I just have to multiply the second fraction by 2. So that I have 5/6 minus 4/6, which is 5 minus 4/6, which equals 1/6. So my value for y is 1/6. And now I want to check that answer. So I take the value of y equals 1/6, and I write the original question, y plus 2/3 equals 5/6, and 1/6 gets substituted in for y, and I want to combine 1/6 plus 2/3, and the common denominator once again is equal to 6, so I just multiply the second fraction by 2, so that I have 1/6 plus 4/6 And I can write this as 1 plus 4 over 6. Both sides equal 5 over 6. So since the two sides are equal, the answer of y equals 1 over 6 is correct. For number 5, 1 and 1/4 equals y minus 2 and 2/3. So to solve for y, I want to add. I take the opposite operation of the 2 and 2/3, and I add 2 and 2/3 to both sides. So on the side here, I will take 1 and 1/4 plus 2 and 2/3. So 1 and 1/4 plus 2 and 2/3. If I change both of these mixed numbers to improper fractions, 1 and 1/4 is the same as 5/4. I take 1 times 4 plus 1, and then 2 and 2/3, I take 2 times 3 is 6, plus 2 is 8, so 5/4 plus 8/3. And to find the least common denominator, I list the multiples of 4 and 3. And the smallest number that they have in common is 12. So the least common denominator is 12. And I have to multiply the first fraction by 3 over 3 so that my denominator is equal to 12. The second fraction I have to multiply by 4 over 4 so that the denominator is equal to 12. And I rewrite both fractions as 15 over 12 plus 32 over 12, which is 15 plus 32 over 12 is equal to 47 over 12. And 47 over 12 as a mixed number can be written as 3 and 11/12. So my value for y is 3 and 11/12. So I can write 3 and 11/12 equals y, or y equals 3 and 11/12. So I found the value for y, but to be sure that this is correct, I have to show the check. So I take y equals 3 and 11/12, which is the same as 47 over 12, and substitute it into the original equation. 1 and 1/4 equals y minus 2 and 2/3, and I'm going to substitute in the 47/12 because to combine fractions, you want to write them as improper fractions. So to determine if my value for y is correct, I want to combine 47/12 minus 8/3, and if I did this correctly, I should get the answer of 5/4. So the common denominator is 12. So when I multiply, both the numerator and denominator of 8/3 by 4, I have 5/4 equals 47/12 minus 32/12. So 47 minus 32/12 is equal to 15/12. And to reduce this fraction, if I divide them both by 3, 15/12 reduces to 5/4, so the two sides match. And the answer of y equals 3 11/12 is correct. For number 6, f plus 1.2 equals negative 2.7. So with decimals, the problem doesn't change with the steps. I want to still isolate f, and I subtract 1.2 from both sides. And negative 2.7 minus 1.2, if I write that out horizontally, negative 2.7 minus 1.2 is the same as negative 2.7 minus a positive 1.2, and I'm subtracting, so I have to use keep, change, change. So I keep the sign of the negative 2.7 and I change the next two signs. So that I have negative 2.7 plus negative 1.2, which is negative 3.9. And to determine if negative 3.9 is correct, I show the check, and I take f equals negative 3.9, and I write the original equation, and I substitute negative 3.9 and I substitute negative 3.9 in for f, and I combine the left side, negative 3.9 plus 1.2, and the way I do that is I subtract the numbers because I'm adding two numbers with different signs, and I take the sign of the larger number. Make sure that you line up your decimals. 3.9 is larger, so it's negative 2.7, and since it equals the right side of the equation, the check works, and the final answer is f equals negative 3.9. For number 7, negative 2.05 equals g minus 1.6. So to solve for g, I'm subtracting a 1.6, so I add 1.6 to both sides of the equation, and negative 2.05 plus 1.6, we are adding numbers with different signs, so the rule is to subtract them, and to take the sign of the bigger number. So 2.05 minus 1.6, I have to add a 0 after the 1.6 because when you're adding and subtracting decimals, your digits must be lined up. And since negative 2.5 is larger, it's negative 0.45 is equal to g, and I can reverse this and write it as g equals negative 0.45, and we just have to show the check. So we take g equals negative 0.45, and I substitute it in for g. And the right side of the equation, negative 0.45 minus 1.6, if I write that out as negative 0.45 minus a positive 1.6, I use keep, change, change, so that I have negative 0.45 plus a negative 1.6, and now I'm adding two negatives, so I take 0.45 and 1.6, but I have to add a 0, and I have 2.05, but because I was adding two negatives, it's negative 2.05. So both the left and right sides are equal to negative 2.05. So the final answer is g equals negative 0.45.